Okay, so I basically remodeled the entire pipe dream set, but in Roblox, and I'll show it to you now. So how'd I do all this? Well, it's actually kinda similar to the way this other recreation was done by Virtual Turtle back in 2018. Basically, way back in 2002, ATI created a real-time version of Pipe Dream that you could actually run on your PC. Like, you could move your mouse, and that would move the camera and stuff. It's pretty cool, so they made their own model of that. And you can actually rip what they used in the final version with a program called Ninja Ripper. But the thing is, though, the models that are actually used are, like, disconnected and stuff, as you can see here. And at first, I thought I wouldn't be able to, like, piece them all together. I thought it'd be, like, way too complicated. But then I realized you could just open them all at the same time and it recreates, like, most of it. This is pretty cool, because now we can just put them directly into a Roblox. And from this, you can tell my model is actually just an exact copy of it, with a few tweaks, because the original model has a handful of mistakes. So I started by scaling everything down so that one ball in the model would be a 1x1 ball in Roblox, because originally it's just huge. And then I started placing down all the pipes, and the turns. The turns were a problem because Roblox doesn't natively support turns. So this was before I had my AutoArc script to do this for me. I just manually built them until they looked right. Basically everything that you see in red, I made first. That's all the cylinders, all the pipes, all the turns, as well as these little box units, which were pretty fun to make. And you'll notice everywhere there's supposed to be a funnel, instead there's just one part. That's because when the game starts, there's a set of scripts that run in a particular order which build everything. And in this case, everywhere there's supposed to be a funnel gets cloned over from a master funnel. And the same thing goes with these two really big funnels, which I call grand funnels. The same idea. Then my first instrument I worked on were these things. I wasn't really sure what to call them, but they have strings and they have bongos, so they're like Stringos. I don't know. This is a good enough name, but I was just copying the ATI demo model, and in this case, I only made the ones on the end and then came back to fill it in later. And the reason why I did that is because this is the problem I had. If you look closely, you can actually see the parts moving around depending on their pitch, while also being spaced evenly along this axis. So I wrote a script that would correctly build it every time the game starts up, and that goes along with the list of the other scripts. So now I can correctly model that the lower strings are longer and the higher ones are shorter. Things like that. The next instrument I modeled was the Vibraphone, which is probably the most involved. First you have this little bass thing which sort of spins around like a funnel, and then you have the arms, which have a total of 3 scripts that run to build them correctly at the start of the game. So the first thing you see here is what the first script does. What that does is it clones part of the arms all the way around, all 40 copies, as well as the 40 funnels on the other side. And for each arm, everything we didn't copy is the block section, with 2 holders on the end and the actual note in the middle. And what the second script does is actually pretty similar to what the Stringos script does, which is sort of interpolates the heights of all of the holders along based on a minimum height and a maximum height. And the third and final one, based on each block's holder, places the actual note in and the strings that hold it. And then the newest instrument I built were the drums. And I think these look really cool actually. Basically, modeling them was mostly like making the pipes, except everything was offset at some weird angle or combination of angles, especially the snare drum. That one's the most complicated. But I don't really have to keep track of the exact angle or anything, that's not important. And my favorite part out of all of this is probably this little four-way thing. I just think it looks really cool. Oh yeah, and as of now, all of the symbols are just placeholder symbols from the original model. In the future, I'll remake them all properly, but as of now, these are fine. So every model I've described so far is made of parts which fall into one of four categories. The first one is it's just a normal Roblox part with nothing special about it. The second one is it's a cone, because Roblox doesn't natively support cones. The third one is shapes like the funnels or the drum heads where parts actually rotate around a center. And the fourth one is any sort of arc or curve using my AutoArc script. So as of now, everything looks like Play-Doh because I haven't finalized the colors of the parts yet. This is just the remodeling phase of things. As for all the funnel parts, a good example would be this Vibraphone center. We can go back to that and you can actually see all the parts inside of it. Before the game starts, it looks like this. Each part goes around the center and you can actually see in the name, the number means how many copies are going to be made in total. And this is useful too because the same logic that moves the parts around can also apply to models. Now the arcs are where things really get interesting. In short, each of them is just a Bezier curve with a bunch of cylinder segments. And the way they're all made is with my AutoArc script, which I've optimized for pipe turns. Each model you want to make into a turn has to have a start part and an end part, and then the cylinders just smoothly go along from there. So a Bezier curve is a mathematically defined way of splining between points. And it turns out with a simple one, you can make a really good circle segment. What it comes down to are these green lines here, and we want to know how long they should be. And I don't know where I found it, but there's this equation which gives us this nice number for us. And you can see by me moving this point up and down, it actually can also make ellipses really well too. And that exact logic is what I based my AutoArc script off of. But then the next problem to tackle was to make them connect properly. The naive approach is to have their centers meet, but then that would just create a bunch of ridges. So, I spent about a week tackling that exact problem. I got pretty good results. Overall still kinda buggy. Also, the bug you see here isn't the actual fault of the model, it's just the fault of the AutoArc script. So I've been working on this project on and off for about a year now, a bit less, and when it came to naming things, I first wanted to denote the special parts from the normal ones, like which models should be used for AutoArc or not. So you can actually see in the part's name a % sign and a flag. The flag describes the object without changing its name. In the order which I created them, here are the 5 so far. The first is AutoArc, which takes 2 numbers. The first number is the resolution, like how many parts, and the second is the thickness of each part, which is either an absolute value or a percentage. The next is a funnel part, which is just all the blocks which the master funnels get cloned onto, and the same for the next one, but just for the grand funnels. The next is called spin, which is basically just all the funnels in the first place in the drum heads before they're spun around. And the last one is an M for motion. Basically any part that moves that's meant to be animated will be flagged that, because every frame you would only have to update these specific parts.